Hi folks, we're going to take a look at number 8 from the second lesson of Unit 5. So here they give us two vectors, but they don't give us the two vectors explicitly. They give us the two magnitudes, but they don't give us the directions individually. They do tell us, though, that the angle between them is 40 degrees. And from there, they want us to first determine the sum of the two vectors. All right? So because they're giving us the angle between them, well, the angle between two vectors is assumed that the two vectors are drawn tail to tail. So that's how I'm going to start off my problem. Okay, now, because they don't give me any direction, all they give me is the relationship between the two. I can draw U and V anywhere. So I'm going to do is I'm going to draw it so I get something nice. So I'll draw, say, U here. Okay. And then I'm just going to draw V so that it's a horizontal one, and it's got to be a little longer than U since it has a larger magnitude. So here's my vector V. All right. Now, when we draw vectors tail to tail, and of course the angle between them here is 40, the sum is just going to be the vector that's created by the parallelogram formed by the two vectors. Okay. So if I take this parallelogram, my resultant vector is going to be this diagonal right here, starting from the two tails. Okay, now another way of looking at this is U plus V, so I can draw the vector there, or I can just think this side here is the same length as vector V. All right, so we have this is equal to 4, and this here, the magnitude is equal to 7. And this is where we have to be careful. All right, 40 degrees is the angle between them, meaning when they're placed tail to tail. But when I'm adding them together tip to tail, the angle that I'm actually going to work with is this one here. All right, and hopefully you can see very easily that because these two vectors are parallel to each other, these two angles are just going to be supplementary. In other words, this is 180 minus 40. So this is 140 degrees. All right, so when you're working in this situation, don't automatically assume that you're going to be working with the angle that's given. Okay, in this case here, we have to draw the diagram to interpret what angle we should actually be working with. All right, so now I can actually determine the new vector. So I'm looking for first the magnitude of U plus V. And so here I'm going to use cosine law. It's set up for cosine law. So here magnitude of U plus V is equal to, now if you need to refresh your memory on cosine law, please do that because I'm going to do these real quickly. So it's going to be the square root. Okay, so it's the sum of the square of the other two sides. So 4 squared plus 7 squared minus 2 times 4 times 7 times the cosine of the angle opposite what I'm looking for. So here, 140 degrees. Okay, so this is why it's very important to make sure we get the correct angle. So let's get our calculator out here and calculate this. So I've got 4 squared plus 7 squared minus 2 times 4 times 7 times cos of 140. All right, and then I'm going to take the square root, so I'm just going to take exponent 0.5. Okay, and here we have 10.4. Okay, probably good to take two decimal places, but I'm going to go a bit quick, so I'm just going to take 10.4. So that's the magnitude. So now what we have to do is we have to find a way to describe the direction, except we don't really have any references to where north, south, east, west, so I can't use that to represent direction, okay, because I could have easily have drawn these two vectors tilted that way. All right, so the way we're going to describe direction is we're going to describe it relative to one of the vectors here. And so if I look at this angle here, theta, which I'm going to call theta, what I'm going to do is I'm going to describe the resultant vector relative to the vector v by using this angle here. Now, this is where I'm going to make a suggestion. In this case here, won't make a difference. It has to do with what I use to find this angle. Now, I could use either sine law or cosine law. Sine law is definitely easier, okay? But when I'm using two sides and an angle to find another angle, that's where the ambiguous case of the sine law comes into play. Now, because the angle I'm using happens to be obtuse, I actually don't have to worry about the ambiguous case, because you won't have an ambiguous case when you're working with an obtuse angle. Okay, but if this angle were acute, as we're going to see in the next example, well, you're going to have to worry about it. So what I do is, just so that I don't have to worry about ever thinking about the sine law unless I have to, is I use the cosine law anytime it's available. So you might say, yes, it takes a little longer, but then I just get used to using it so I don't get caught using it when it'll give me an ambiguous case. All right, so what I'm going to do here is to find this angle theta. And again, I'm going to assume we know the cosine law really well, so definitely review this if you need to. Well, it's going to be cos inverse of, okay, so first I look at the opposite side of what I'm working with, which is the 4. So it's going to be 4 squared minus the square of the other two sides, so minus 7 squared minus 10.4 squared, the one I just found, divided by negative 2 times these two sides, okay, 7 and 10.4. All right, and so that'll get me my angle. So let's go back here. So we've got inverse cosine. Open up a bracket for the numerator. So we have 4 squared minus 7 squared minus 10.4 squared. Close the numerator bracket. Oh, and I see I made a little mistake. So put a little point here. Oh, I guess I'll just delete. Sorry. I guess I'm going to start over. Let's try again. Cos inverse, open bracket, numerator bracket. So again, 4 squared minus 7 squared minus 10.4 squared. Close the numerator bracket, divided by, open the denominator bracket, negative 2 times 7 times 10.4. All right, and that gives me 14.2 degrees. Okay, so now I have to give my final answer. So what is U plus V? Well, I'm first going to give the magnitude. That's what we give first. So it's 10.4 units. And now I have to describe the direction. And this is where I'm going to say, and it's a little complicated, but it does describe what's going on. It's 14.2 degrees from V. So from vector V in the direction of vector U. Now, what's nice about this description is no matter how I had drawn this scenario, I would end up with the same relationship. Okay, now had I worked with this triangle up here, okay, I would have probably been describing it from vector U. Either one of them are completely valid because U plus V is the same as V plus U. Okay, so just to recap here, number 1, get a good diagram. Number 2, recognize the difference between the angle between the two vectors and the angle that you're actually going to use in your calculation. Okay, and step 3, in some cases when they don't give us explicitly the directions of the two vectors, we describe the direction relative to the vectors that are given. Okay, that's it for this one.